just yeah, what was the last concept that we have discussed?
I think it was the banked road, right?
Yeah,
Motion.
I think we just have started with
Yes.
motion of the vehicle on circular track, right?
Yes, ma'am.
Okay. So first we had to discuss the case of unbanked or a level road, and then we had to go for a banked road, correct?
Yes, ma'am.
Okay, so yeah, I'll just share my screen. Before that, just a minute, I'll add two pictures here.
Yes.
Hope you may have noticed, like when if you're traveling on a road, you may have noticed wherever there is curving, okay, like some kind of a circular turn, like curving, you notice that the inside part will be somewhat leveled down, right? And the
Yes.
outside is like little bit leveled up, correct? Some inclination is being provided. Have you seen it?
Yes, ma'am. Those racetracks and all.
Yeah, I mean, there it becomes very essential. In our normal track, I mean, usually with large turnings, it will be definitely, done. But definitely with the racing track and all, that proper, inclination must be provided, or else, because of high speeds, there may be the skidding of the vehicle will take up. Okay, so that's one thing. So here I just have added the pictures, like if the vehicle is just moving on a leveled track, so how it's free body diagram. And in the next one, yeah, we had to discuss in detail about the second case where when the object is moving on some inclined tracks, okay, or like a inclined or banked road. Okay, so how do you bank it? Like if the turning is like this, okay, if it is like this, so what happens? So inside will be banked, okay, the inside track will be leveled down, or the outside of the road has been little leveled up. Okay, so this is like a cross sectional view, that is what given here. Okay.
Yes.
Yeah, so okay, I'll just go with my writing screen and we'll just start straight away. See, the point is, if a car is moving on some curved roads, like some part of a circle, we can imagine, right? If there is some a straight road, then it may take a turn like this, correct? No, so it can be imagined like some circular, some part of the circle. And we already studied something called as circular motion. If some object has to take a circular path, what type of force that is necessary?
Centripetal.
Yeah, it is centripetal force. Like whenever there is circular path or circular trajectory, definitely the force nature should be centripetal in nature. Okay, and what is the expression for that centripetal force?
Uh,
Do you recall centripetal force equation?
just that FC is equals to
Yes.
V square by R. No.
Yes, mv square
MV
by r,
square.
correct, that itself. Okay, so centripetal force is mv square by r. Centripetal acceleration is just v square by r.
V square.
Okay, so that's all we do here. Okay, whenever this is the basic point that we consider in all motion along the curved tracks. So what we do is, like the vehicle, like a car is taking a turn along a circular path, so definitely there must be centripetal force, okay, which makes the car to bend in this circular path. If that force is not there, the car will just go like this, correct? It just moves in a straight line. There is some force which acts towards the center, so it is possible for the car to take a turn. That's all the idea. And now we need some centripetal force. We'll see which can act like a centripetal force. Okay, that is the next question. Now, when you consider the motion of the vehicle, or it's, let us say this is just a level road. I'll just let us say this is some vehicle. So what are all the forces that we can see? We can see the weight which is acting vertically downward. And obviously there will be a normal reaction which is acting upward, correct?
Yes.
And there will be the friction which acts along the tangential direction, correct?
Yes.
Yeah, there will be friction. Okay, so now the point is, okay, imagine like the car is moving, in this particular diagram, the car is moving towards us. Okay, so the point is, I can tell you in two different ways. Like, one is your normal reaction is not acting along the surface. It is perpendicular to the surface. Yes or no?
Yes, ma'am.
So definitely your normal reaction cannot able to give you any kind of centripetal force, because centripetal force means it should act, along the horizontal directions. It should act on the surface, correct?
Yes, ma'am.
So this normal reaction is not going to give you any centripetal force. Then obviously weight, and we could see like your normal reaction and weight is balanced. That's why the car is not flying up. It is just still on the road, correct? So that means your N must be balanced by mg, correct? And it has nothing to do with centripetal force. Then who is giving us the centripetal force? Now, by the definition of contact force, the force which acts along the surface which are in contact is nothing but frictional force, correct? Only
Yes,
this is the force which is possible, which can provide us the centripetal force, because definitely there must be centripetal force, or else the car would have just moved in the straight path. Somebody is giving us the centripetal force, and definitely it is not normal reaction, not the weight, because they are acting in the vertical directions and they are balanced also. Now, what is the force which I can see? The next force, I can see that there is some contact force which is along the surface, and by definition we call it as frictional force. Then we must have to say the frictional force is providing the necessary centripetal force. Understood? The frictional force is providing the necessary centripetal force.
Okay.
Understood till here? Now onwards, it's just few maths, and we'll end up with the expression for safe speed for a vehicle to move on a leveled road. So I think this explanation is clear to you. Is it fine?
Yes, ma'am.
Yeah. So now I'll just share my writing screen, and we'll just get the expression for safe speed on the level road. Okay. So what we are trying to say is the normal reaction is balancing mg. Okay, so we are, okay, let me just write the heading as well. So we are trying to get the expression for velocity, like safe speed, expression for safe speed on level road. Okay, so this is what we are doing now. Okay, so this is first condition. Like normal reaction is balanced by the vehicle, weight. And now, hope you agreed to the point that the centripetal force should be provided from the frictional force, correct?
Yes.
There is no other force that we can see in the picture. So obviously, the frictional force provides the necessary centripetal force. Okay, that means, so what is the expression for centripetal force? Like mv square by r. Okay.
Yes.
Should be less than or equal to the frictional force, where small f is frictional force. Here also I should tell you a few points. What is the expression for frictional force, like maximum frictional force?
There's this thing, V max square by R, right?
No. That is centripetal force. Frictional force equation.
That mu s.
Correct. Mu s into n. Correct?
Yes.
This is like limiting friction, or the maximum static frictional force is mu s into n. Correct? So
Yes, ma'am.
now see here. We are moving on a leveled circular track, like this is leveled road. Okay, so that is what the picture is. We have not banked the road. So in that particular case, okay, if the frictional or if your centripetal force is more than the frictional force, what will happen? Because I'm writing like frictional force must be less than, sorry, your centripetal force is less than or equal to frictional force I'm writing. So let us imagine this is the some vehicle which is moving in this direction. If like centripetal force will be acting in this way, do you agree? The centripetal force will act in this way, yes or no?
Yes, ma'am.
So now your frictional force should be, or your centripetal force should be less than or equal to frictional force, yes or no?
Yes, ma'am.
If it is more, like centripetal force, if it is more, what happens to your the moving vehicle?
It stops. I'm not sure.
See, the point is, now let us imagine what is the role of friction here. I already told you, like the friction acts along the, the point where the tires are in contact with the surface. So like your, the centripetal force must be provided by the frictional force. Yes or no? The centripetal force must be provided by the frictional force. That means your frictional force is acting in this way. If this friction is not there, what might have been happened? It's like, the car will leave this circular track and it just goes in straight direction, which means leaves the circular path and it just goes in, it's whatever the velocity direction at this particular point, it just goes in this direction, correct? So your centripetal force will be less than or equal to the frictional force. Like the car has a tendency to move in, we wish the car to move in this circular path. If this friction was not there, so the car would have been moved away from the circular track. Okay, so now always, if for in case like the speed is very high, like some person is driving with very fast speed, now what happens? The frictional force becomes, insufficient. Okay, the frictional force become insufficient, and then the car has a tendency to slip into the track itself. It will not go in actual.
Centripetal force increases, it crashes.
Centripetal force is now increased because the speed is more, correct? So it will cause this particular vehicle to leave its circular path, and it towards the center the force is more, it just slips to the inside of the track, correct?
Yes.
So always your centripetal force must be less than or equal to frictional force. So there is a proper balancing between the friction and the centripetal force. Okay, because friction has a maximum limiting value, like its limiting value is mu s into n, correct?
Yes, ma'am.
Your static friction cannot exceed than this. Okay. Yeah.
Yes, ma'am.
Yeah. So now what happens is that, so under the limiting case, you can consider like I can just write the expression for mv square by r. The maximum value that can be should be equal to the maximum static friction, which is like mv square by r should be equal to mu s into n. But what can be written for n? So mu s into m into g, where m is the mass of that vehicle. So m and m goes away. So you get something like v square is equals to mu s into r into g, or the maximum safe speed will be square root of mu s R G. Okay, mu S R G. So this is without skidding, the maximum speed with which a vehicle can move on a level road without skidding, or it's like safe speed. Okay, the words will be used like that, without skidding. Okay.
Yes, ma'am.
Is it clear?
Yes, ma'am.
Yeah. So now, like, here the problem is that now, because like friction can have like some maximum value, and this radius of turning, it depends on which turn we are taking, like which road you are traveling, and G is a constant, correct? So these R and G are not in our hand. Mu S is also sometimes it is not in our hand, because if there is a if it is a rainy day, so friction will be automatically reduced, or if some nature of the tracks are different, automatically there is some change in the frictions, right? So
Yes.
which puts a limit on the speed with which we are traveling, because if you increase your speed, now friction fails to provide that centripetal force. Okay, friction is fail to provide that centripetal force. Okay, so now the car will have a tendency to leave the circular track and it just goes in this direction. Okay, it just goes out of its circular track. Okay.
Okay.
Yeah. So now, like it's practically it is a problem now, because we don't know. We may go from one road to other road. We don't know what is its coefficient of friction and all. We cannot, while driving a vehicle, we cannot just calculate. Okay, this is this type of road. That is that type of road. This is this much of turning is there for that road. This much of turning is there. So I should go with this speed, or you cannot calculate instantly, right? So that means it's a high risk here. Okay, it's going to be a high risk. So to avoid this, what we had done is somehow we had to improve the speed. Okay, improve, or we had to increase the value of safe speed. For that, what we do, we actually go for banking of the road. Okay, so what we do is we go for banking of the road, and apart from, because the problem here is entire centripetal force must be provided from the frictional force. Okay, but now what we do in such that some portion of the centripetal force also provided by something else. Okay, something else. So what is that something else? So now instead of talking about car, we will talk about cycles or bicycle. Okay, so if you have observed, when if you are moving with little fast speed on a bike, or if you are driving with little fast speed or with a bike or a cycle, and if you are taking a turn, what do you usually do? You bend yourself, right? You lean towards the track, yes or no? Instead of going on a straight thing, you just lean, correct?
Yes, ma'am.
So that is bending is what you usually observe. That means what you try to do is some portion of the centripetal force, you try to get it from the your weight itself. Okay, or like a part of normal, from a part of the normal reaction. So with bike, like with the two wheelers, you can achieve that. You can bend yourself, or like you can bend. I mean, yourself means along with the cycle, right, or along with the bicycle. But can you able to do that with the four wheelers or any heavy tracks and all? No, right? We cannot actually able to do that. Like that will leads to a toppling, right? So if you imagine just like if this car try to bend, so like maybe the outer two tires will just leave out of the come out, no, it just lift up from up the surface, which is not expected, right? So in such case, instead of bending the vehicle or the the object which is moving, what is done is the road itself has been banked. Okay, it's like the same two thing, either you should bend or the road should have some banking. Okay, so that is what, to achieve or to increase the safe speed on a turning. So what we do, there are two possibilities can be done. One is bending yourself, like how you do it in some two-wheelers, but for four-wheelers it is discarded. So something we should do. So for that, what we do is, you take the road itself is been made a banking. Okay, so something, from inner edge to outer edge, so you just slightly lift it up. No, okay, outer edge will be slightly at higher point when compared to the inner edge of the track. Okay, hope you're getting that visualization, because I'm just drawing it on, no, just a free body diagrams kind of a thing. Okay, so that is the case. So we'll just look here. Hope you can see the diagram now, which is shared on the platform itself. Yeah.
Yes, ma'am.
Yeah. So now the point is here, as I said, either you should bend or the road should be banked. So what we had done here, we made the roads are slightly banked. So what do you mean by banking of a road? The phenomena, I'll just do here. Of rising the outer edge.
Ma'am, in our notes, in our class which ma'am had given us, she had written, we can reduce the contribution of friction to the circular motion of the car if the road is banked. How does that happen?
We are actually not reducing the friction. We are actually reducing the dependency on the friction. Okay. So what we are doing, see, this friction, what we write here, it's a self-adjustable. And it has some maximum value. Now, if some component of the centripetal force is provided from this, the normal component, some less part of friction is enough now. Okay, that's the advantage of having a self-adjustable force. Your frictional force is a self-adjustable force, and with the last example, like when we calculated the velocity, what we did, we have taken it to the maximum possible static friction. Beyond that, your static friction will not increase. For every given two surfaces, there is a maximum limit on it, and that limit is equals to mu s into n. Correct? It can go from 0 to mu s into n. Correct?
Yes, ma'am.
So now, by making some kind of banking, what we are trying to do, in the earlier case, there was no other force which was giving us centripetal force. Now, and solely we had to depend on frictional force there. But that friction is somewhat a variable one, because it depends from road to road, turning to turning. We cannot get a proper gauge of what is the safe velocity. So now, in order to avoid too much dependency on friction, we are making something like a banking, so that some portion of the centripetal force you even get from the component of the normal reaction, and some portion, if that is not sufficient enough, then obviously some friction is there that will provide you the rest centripetal force. That is how the idea is. Understood?
Yes, ma'am.
Got it or not?
Yes, ma'am.
Yeah. The phenomenon of rising the outer edge of the curved road. Okay, just a minute. Yeah. Okay, outer edge of the curved road above the inner edge. Above the inner edge is called as banking of road. Okay, it's called as banking of road. Yeah. So now, yeah, are you there?
Yes, ma'am.
Yeah. So if you observe here, let me just erase all those things. We'll first see what are all the way the diagram has been drawn. So, like, hope you can see this is the inner track, okay? Like this. The track is like this.
Yes.
Okay. So outer edge has been slightly leveled up when compared to the inner edge. So this is the circular track. Okay, something like this. So now see here, this is just like a cross section is being drawn. Okay, just imagine like you cut over at this position. So you see like some with the outside you have raised it up. Now it somewhat looks like an inclined plane, right? Here.
Yes, ma'am.
So that imagination should be there. So now, obviously, we'll just see what are all the forces that are acting. First, you, without thinking twice, you can say there is the weight of the vehicle which acts vertically downward. That is mg. And then to the surface, now it is not a level surface. So to this surface, normal, you will have the total normal reaction. Okay, always your normal reaction will be perpendicular to the surface in contact, right? This is surface in contact, so it must be perpendicular to this surface. Do you agree?
Yes.
So that is your N. Next, what else we can see? Your friction makes certain angle here with the angle of, friction is making, but it is acting in this direction, like, along the inclined plane, correct? So that is what this F here. Okay. And there will be centripetal force which acts so that the car is taking this particular circular track. Okay. So that is centripetal force which you had to draw it towards the center. Correct. So that's why it is drawn in this direction. Okay. So now it is very clear here. Like this is the friction. I mean, this is the level surface along which you have friction, and this is perpendicular to the level, like the horizontal line. Mg will be always perpendicular to horizontal reference line. So this is like here some angle theta is there. Obviously this angle will be theta, right?
Yes.
The friction with this horizontal line. So now that friction can be can be resolved into two component. Like one is F cos theta in this direction, one is F sin theta in this direction. Yes or no?
Yes, ma'am.
Correct, no? So
yes,
we have resolved friction into two components, F cos theta and F sin theta. Similarly, you have a normal reaction here. Now that makes an angle theta with the normal to the horizontal reference line. I had told you one, one rule that if the angle between two lines is theta, then the angle between their perpendicular will also be theta. Okay, so you have to apply that logic, and you can see that this will also comes out to be theta. Now this component is n cos theta, and this component will be n sin theta on resolving. Correct?
Yes, ma'am.
So now what are all the forces are acting on? What are all the direction? So like our centripetal force will be obviously this direction. So the centripetal force should be provided by F cos theta and N sin theta. Do you agree?
Yes, ma'am.
Yeah. And now the entire normal reaction is not balanced. Only N cos theta should balance the F sin theta and mg. Do you agree?
Yes.
So we can write those two equations. So first I'll write that. Okay.
Ma'am, will you stop sharing this screen?
You are not able to see that?
It's showing tutor is presenting.
I mean, I shared my writing screen. 1 minute. I'll reshare it.
Okay.
I think your signal is also showing low now. So it may take little time. There might be some lagging. Yeah. Can you able to see it now?
Yes, or now I can see the black screen.
Okay. Huh. So I had written banking of roads there. Can you able to see that? Now, with the banking of roads, if you consider that particular diagram, so what we can write, the n cos theta is the component of normal reaction which is perpendicular to the horizontal reference line, is balanced by mg plus f sin theta. Correct? If you refer that diagram, so you will get this as your first equation. Correct?
Yes.
And now the second equation is the centripetal force, like mv square by r, is now provided by two things. One is n sin theta, that is the component of normal reaction, plus f cos theta. Correct?
Yes, sir.
So now we can do is see here we have got two equation. So at the end we want to get some expression for v square, correct, or v, like the safe speed here, what it is going to be, and somehow we need to say by doing this speed what we get here, no, it should be greater than this mu rg, because already mu rg is there with the level road. So our intention is to increase that speed. Correct? Yes, or no? So now what we'll do is we'll put the value of frictional forces in the two equation. Okay. So what we are going to get, frictional force, the maximum frictional force that is possible is mu s into n. Correct?
Yes,
mu s into n. So I'll just put here itself. So what you get is mg plus f can be written as mu s into n sin theta. Correct? Mu s into n sin theta. And here if I write, so what do I'm going to get? N sin theta plus mu s into n cos theta. Correct? Yes or no? Yeah. So now what we can do is, just a minute. So we can eliminate n now. So from this particular equation, okay, what you are going to get is like n can see here, here is one n term, here is one n term. So I can group it. So n cos theta minus mu s n sin theta will be the term. So will be equal to mg. Do you agree? So I can write n is equals to, so mg divided by cos theta minus mu s into sin theta. Correct? Mu s into sin theta. Correct? I just have taken, I have regrouped these two terms like this and this. Taken n common, then what you get, cos theta minus mu s sin theta, and then here mg is there, so mg divided by that. Correct?
Yes.
So that is one equation. And now here also if I do the same thing. So what do we have? There is one term here, one term here, no? So what you will get? N, if you take common out, so mv square by r is equals to n into sin theta plus mu s cos theta. Correct? Correct now?
Yes.
So now what you can do, you have the value of n, you can substitute here. mv square by r is equals to, n means what you can write?
mg by cos theta minus ms mu s sin theta.
Yeah, mu s sin theta into Sine theta.
Will this theta sine theta cancel?
Huh?
This sine theta and that sine
No,
theta.
because this is in the addition form. No? It's not just
Oh,
sine theta. It's sine theta plus something is there. Here minus mu s sine theta, and here some cos theta is there. It's not in the product form, right?
yes.
So what you get, mv square by r is equals to mg sine theta plus mu s cos theta divided by cos theta minus mu s sine theta. So now what we will do is, just little more calculation, because we want to get some expression for v. So you can send this r here. You can cancel m and this m, correct? So what you will get, v square is equals to r into gl, right? Here the left out term is sine theta plus mu s cos theta divided by cos theta minus mu s sine theta. Okay, so now we'll do one more step, like divide by cos theta throughout. Okay, so what you will get, v square is equals to rg. Okay, so if I divide by cos theta, like sine theta by cos theta will give you tan theta, no? Plus mu s as it is, then cos theta by cos theta will give you 1. Here again cos theta by cos theta will give you 1 minus mu s tan theta. This is the usual standard representation. Okay, or you can just rewrite, we want v, this is v square, so v will be square root of this, so rg into mu s tan theta divided by 1 minus mu s tan theta. Rise to power half, everything whole rise to half, correct?
Yes, ma'am.
So this will be the final expression. Okay, so rg into mu s plus tan theta by 1 minus mu s tan theta rise to half. So this will be the maximum safe speed on a banked road.
Okay.
Okay, on a banked road. Okay, so now you can see, like, you know, can you check, like, is it is greater than our previous equation? The other equation what we had is mu s rg, that's all, no? So we had velocity is equals to mu s into r into g. Like rg is fine under root, no? So that term is there. Now do you agree this mu s plus tan theta divided by 1 minus mu s tan theta will be greater than mu s? Do you agree?
Yes, sir.
Yeah, obviously it is increased, right? So that is what was the purpose of you know, making the road as banked. Okay, so that means we just have you know, reduced the risk of skidding. Okay, even you can like have comparatively more speed on a banked road. Okay,
Yes, sir.
yeah, so like obviously, no, this v is greater than this mu s rg, definitely, correct? So obviously we can say that by making the road as banked, we have actually increased the safe speed, that is without skidding, the car for the vehicle to move without skidding. And the other importance is that this equation, like both, has no dependency on mass of the vehicle, right? Whether it may be a truck or whether it may be a car or any other vehicle which is moving, it has nothing to do with the mass of the vehicle. Okay.
Yes.
It is completely independent of that. It just depends on what is the angle of banking you had done, what is the friction of that particular road, and the radius. Okay.
Yes.
Yeah. See, like if you can increase the radius of turning, okay, instead of having a sharp turning, if you just somewhat you increase the radius, okay, so somewhat you can even improve the speed. But that is practically not possible in all the situation. Like having the roads of larger radius, that is not practically possible in all the cases. So that's why we go for some practically feasible solution. That is what is banking the road. Okay.
Yes.
Any doubt?
No.
Okay. Just once go through the steps here. I'll just show it to you from the beginning. Just have a look about it and then we'll go ahead.
In just 2 minutes, can I just copy it?
Yeah, please copy. The first one also you want?
Yes, ma'am.
Yeah, please copy it. You please refer the diagram from that which is on the board, okay? You can later copy it down. You just download and you can copy it. Or you can refer that NCERT, the same diagram it is actually. Okay.
The figure 5.14, right?
Road, okay? Same diagram. You can just refer that. Whenever you write something in exam, please, diagram is mandatory. Okay, it is must and should. With diagram only you have to state all this, okay?
B diagram you have to draw it.
Huh?
The B diagram.
Like for both. Even
If
the
the
question is about level road, you draw first one. If the question is about the bank road, you draw the second one. Okay. In that B also, if you cannot able to draw that the diagram with the car, you can ignore it. You can just draw the free body diagram. That much is enough.
Yes.
Okay. But free body diagram is necessary, and you should tell what are all those forces. Like you should mention that small f is for friction, N is for normal reaction. Like that you have to specify. Okay. You no need to draw that car and all. You can just put some box. Okay. Just free body diagram. You can just draw a box and then mark properly the direction of the force. That's all is what necessary.
Okay.
Yeah.
Ma'am, can you scroll down?
Yeah. Completed till here? Let me know.
Yes. Yeah, scroll down.
Yeah.
Scroll the last.
Yeah. So here, this one step you should remember. Like you divide throughout by cos theta. For each and every term. Okay. To numerator and denominator. So that you are not altering the value.
Yes.
Yeah.
No.
Completed.
Yes.
Hope you understood now. At least a little bit there. So it's like earlier we had to depend completely on the frictional force. Now we have reduced the dependency of the circular motion entirely on this frictional force. Now some contribution is there even from your normal reaction. Okay. Like that banked angle. Okay. So now we'll see that case. Like if I say the vehicle is moving on a perfectly smooth road. Okay, this is the special case. If smooth road means what? Coefficient of friction is 0. Mu s is equals to 0. Correct. So what we'll get? The safe speed is equals to RG. Entire thing is under square root tries to half RG into mu s 0 means tan theta here divided by 1. So which is simply root of RG tan theta. Okay, so it depends on how much is the banking. Even though friction is 0, but you have some safe speed. You can even travel with the speed equal to RG tan theta. But if in the circular motion case without banking, like on a level road, if friction is 0 means you cannot able to take a turn at all, because the entire centrifugal force is provided by frictional force. Okay.
Yes.
Yeah. So next I think this chapter is this was the last topic, right?
Yes. Solving problems in mechanics.
Yeah. So that means how to draw a free body diagram and all. Okay. So we'll take some simple cases and we'll apply the we'll make comfortable with solving problems. Okay. So I'll just give you. I mean, have we discussed about free body diagram earlier? No. Okay. So when we say something like free body diagram. Okay. I mean, whenever we try to solve some problems in mechanics, first what we do, we draw a free body diagram. So what do you mean by free body diagram? Here we mention or we show like we mention all the forces acting on the system. All the forces acting on the system. Like first we have to define what is our system. First you have to define system. Like system means nothing but which particular part or which particular object is your interest now. Okay. You can consider given problem as a system, or you can divide it into some. If there are two objects, you can imagine like one as your first system, the other as your second system. So define your system properly. Like while defining the system, it is in our hand. I should know by defining something as system, there must be some easy method to solve the problem. Okay, that's the only concept. Okay.
Yes.
And you have to consider all the forces that are acting on the system. And you will not be considering any forces that are acted by the system. Understood? The difference? If there is some block, okay, and there is some small one more block which is in contact with it. Now let me say I apply a force here. Okay. Now in this case, if I say this is my system now initially, so I should consider only that block, and I should draw the forces which are acting on this force. This object. So what are all the forces are acting? Like some force in this direction. Do you agree?
Yes.
And then there will be weight which is acting downward. Do you agree?
Yes.
And if it is kept on some surface, there will be normal reaction acting on this body because of this surface. Correct. And you're not supposed to mention the normal reaction given by this body to the surface. Like Yeah. So that
So
you are not going to mention. You will mention only those forces that are acting on the body, not by the body. Okay. So like the normal reaction acted on this body is upward. But equally it will also give some normal reaction on this particular body, no? That will act downward, but we will not consider this. When I am interested about this particular block. Now if I say stable is my system, then I have to show only this downward normal reaction. Okay.
Yes.
Yeah. And now coming to the second block. So what are all the forces acting on the second block? Now does the force you see like it is acting on the second body? No, right? That force is acting only on the first body. Correct. So this is where like our intuition may sometimes leads to a wrong assumption. Like this force is acting only on the body. Okay. But because of this force, this object will move forward. It will give this second block kind of push. Okay. That can be said like some normal reaction. Because I could see this block and the small block are in contact with each other. Correct.
Yes.
And now what I can see. So there will be some normal reaction by the block 1 on 2. So let us say something like N2 is acting there. The force F is not acting on the system. Only N2 is acting on the system. And again, you can mention all the no, there will be weight of this. I can say something like M dash into G. If I say the mass of this is M dash, there may be something like some other normal reaction. Let us say like N dash. Understood. So defining system is also very important. And when you are mentioning something as system, you should be clear that what are all the forces that are acting on the system. Okay.
Yes.
Is it clear?
Yes.
Yeah. And then the next step what I suggest usually is once you mark all the forces acting on the system, then if the system is in equilibrium. So then you should say the net force acting on the system is 0. Okay. It is like the net force along x direction should be equal to 0. Like you add all the force and make it to 0. Okay. Summation. Not just one force. And summation over f, like y directional force must sum to 0. Correct. And it's like force is a vector quantity. Some direction to be taken positive. Some direction to be taken negative. Or in other words, you can say upward force must be equal to downward force. Left side force must be equal to right side. Correct.
Yes.
Yeah. So vector sum. I'm talking about vector sum. So that's why you had to take direction. So this is for the case of equilibrium. Like if the system is at rest. Okay. The other possibility is like if the system is accelerated. Okay. If the system is accelerated, then you should write F net is equals to the mass of the system multiplied by its acceleration. Okay. So that means to be all the forces, summation over the forces along fx. I mean along x direction should be equal to m into acceleration along x-axis and summation over fy should be equal to m into ay. Okay. Separately you have to write along for x and along for y direction. And again, when you are doing this, you have to be little careful. the force along the acceleration will be taken as positive. This is the convention we usually follow. Force along the direction of acceleration is positive, and force acting opposite to acceleration. Should be taken negative. Is it clear? Like if the block is here, let me say it is accelerated in this direction. Let me say there is one force F1 acting in this direction, F2 acting in this direction. Now which should be taken positive?
F1.
Yeah. F1. Like when you write the equation net force, like F1 minus F2 should be equal to M into A. So this is what the meaning of writing F equals to M. Net force. When I'm writing net force, I should consider the corresponding directions as well. The directions along the acceleration to be taken positive. The forces opposite to the direction of acceleration to be taken negative. And then you will write F net equals to M into A. Understood?
Yes.
Is it clear?
Yes.
Yeah.
Yes.
Just a minute. So I think in Saturday class we can take up some problem on this chapter. Like free body diagram problem, if you prefer. That we can take up. Correct. If there is some particular problem you want me to discuss, you can tell me priorly, so that I can discuss in my next classes.
Okay.